In this chapter, we will be studying trigonometry. In this lesson, we're going to be reviewing the basic trigonometric functions, or SOHCAHTOA for short. Okay, hi everybody. So we're going to continue on with our work in trigonometry. We're going to look at what we call SOHCAHTOA, part one. We're going to split this up into two different parts here. But this is about where we actually introduce what we call the trigonometric operations or the trigonometric functions, okay? Now remember, we're going to start with relative labeling. There's a few different ways we can label a triangle. We're going to start with relative labeling right now. And the way we do that, or the way that we undergo relative labeling, is we first of all focus on an angle, what we're going to call the reference angle in this case. It's going to be the most important angle in the triangle. So it's either the one that we're given, or it's the one that we're being asked to find. Either way, when it's a trig problem, the emphasis is on an angle, one way or another. Like, again, either it's given or it's one we're being asked to find here. And then what that allows us to do is label the sides based on their position relative to the angle. Okay? So now the hypotenuse is the hypotenuse. It's going to be opposite the 90 degree. Not going to change that. That's the way that's defined. But when we talk about the other sides here, a side can be opposite the angle that we're given, or it can be adjacent to the angle that we're given. Now, when we say adjacent, we mean next to or beside. Basically, it is being used, it's used to make that angle. Okay? The opposite side is not being used to make that angle. Remember, every angle that you draw there, you're going to have to draw two lines. Okay, so in a triangle here, right angle triangle, here's my hypotenuse. It's opposite the 90 degree. This is the adjacent side. This is the opposite. The adjacent is one of the sides being used to make the angle. The opposite isn't. It's on the other side of the triangle. Now, we focus on the reference angle, okay, because of the way it helps us define these things. And that's going to change depending on which angle it is that we're specifically focused on. So if we're focused on this angle, this is our reference angle, this side right next to it, this one's the adjacent, but this one's the opposite side. Now, if I take that same triangle, okay, copy it out here, but this time I focus on this angle, well, that changes how I define the opposite and the adjacent. It doesn't change how I define the hypotenuse, just the opposite and the adjacent switch. But it's important that we know how these labels are related to the angle. Our focus is always going to be on the angle. And so we're okay with the fact that they switch, okay, depending on which angle it is that we're looking at, because we're comfortable with the angle being the way we define that. Totally cool. Now, anytime I do this, I pick an angle, and I've labeled these sides here. Turns out there are different ways we combine these sides to produce ratios, okay? I can combine the opposite and the adjacent. I can combine the opposite and the hypotenuse. I can combine the adjacent and the hypotenuse. There's a few different ways that I can take the lengths of those sides and group them together to produce different ratios here. We give those specific names. Okay? Now, because our labeling changes depending on which angle we're interested in, when we start to talk about the different ratios, we need to specify what the angle is when we write out that ratio, or else I don't know where my opposite is, where my adjacent is, how this relationship fits into the actual work here. So we have three primary trig ratios that we use: sine, cosine, and tangent. The sine ratio for a given angle is going to be the length of the opposite side divided by the hypotenuse. The amazing thing, okay, about triangles is that it doesn't really matter how big this triangle is. It makes no difference. Okay, it could be dealing with a really small one, really big one. If it's a right angle triangle and this angle is the same, if this is like a 30-degree angle and this little triangle, and I draw a big one that maybe, goes for city blocks, it doesn't matter. The ratio of the opposite length to the hypotenuse is going to be the same. We call that sine. If we're going to compare the length of the adjacent to the length of the hypotenuse, doesn't matter how big the triangle is. If I've got the same angle, those will always be the same. And then the tangent is the length of the opposite side divided by the length of the adjacent side. Okay? So these are our three primary trig ratios. And if you haven't at this point here, you should see where that SOHCAHTOA comes from. Okay, this means sine is opposite over hypotenuse, SOH. Okay, let me put a capital H there. Cosine is adjacent over hypotenuse, CAH, and tangent is opposite over adjacent, TOA. Okay, and that's where that labeling or that word there comes from. Basically, whenever we say SOHCAHTOA, we're really just referring to the primary trig ratios. There are some things that we can do later on to build on these, but these are the primary trig ratios. So, when we're taking a look at a trig ratio here, for example, the tangent of some angle theta, and I didn't specifically state this, but we use theta, the Greek letter theta, which is just a circle, a zero really, with a line through it. Okay, we use this to represent angles. Okay, we take it from the Greek alphabet, and in a lot of cases, when you see a lowercase Greek letter being used in mathematics, it frequently refers to an angle. Okay, just a little kind of rule of thumb there. So, and theta is the most popular one that we use when referring to angles. In almost every case, when you're seeing theta, it's an angle that we're referring to. So remember that when we're building this trig ratio and we're writing this out here, first of all, we identify what the ratio is, what the trig function is. Okay, we need to specify the angle because my definitions change depending on the angle that I'm using. Okay, which side is called opposite, which side is adjacent, depends on what angle we're focused on. And then for the tangent, tangent is the opposite side divided by the adjacent. So the tangent of the angle there is going to equal the length of the opposite side divided by the length of the adjacent side. So we've got this ratio here, which is comprised of this, like the top number and the bottom number. Okay, so we want to know what those are supposed to be for each of those trig ratios. Now your calculator knows what the sine, cosine, and tangent should be. And if you look at your calculator here, okay, most of us have these. We've got the sine, cosine, and tangent. The calculator knows what those ratios should be equal to for any given angle that you plug into it, which is really convenient. We're going to show you how that works in just a moment here. Anyway, let's flip the page here. And we're going to get into some solving here in just a few moments. But before we do, what we've just looked at here kind of leads to four basic questions that could be asked when we're coming up with when we're using trigonometry. So just to go back to what we had there, we had tangent of theta is equal to the opposite over the adjacent here. Now, what could I be asked? Well, I could be asked to find the ratio. So being asked to find the ratio, what I'm asking you for is this ratio right here, opposite divided by adjacent. I'm saying, like, for a specified angle, when I take the opposite side divided by the adjacent, what number do I get? Sorry. What number do I get? I could be asking you to find the angle, in which case I would give you this right here. I'd give you this ratio, or I'd give you enough information to find it, and then I'm looking for theta. So that could be a possibility. We'll take a look at how that works in a second. I could be asking you to find in the ratio either the numerator, the top number, or the denominator, the bottom number. So I might be asking you for example, the length of the opposite side to the angle, or the adjacent side to the angle, or I might be using sine or cosine and asking you for the hypotenuse. So those are the four different things that we could be asking. But it doesn't really matter which one we're doing. It always starts exactly the same way. Every time we do this, we have to start by this. You've got to identify what that angle is, that reference angle. Okay, it might be the angle that you're given. It might be the angle that you're looking for, but that's how we define our opposite and adjacent. Okay, that's how we are able to accomplish our relative labeling here. Okay, so now in this lesson, we're going to look basically at the first two. We're going to look at how to find the ratio, and then we're going to look at how to find the angle. We'll show you some examples of those. Okay, So let's take some time here and let's use what we know here to find the ratio. Okay. So sometimes that's what you're going to be asked for. What is the ratio that corresponds to a given angle? So here we go. So let's say you're given an angle here, and I just want you to find what, for example, the sine of 42 degrees is. Now, I'm not giving you any other information here. So this is going to be found in the calculator. But what I'm asking is this. If I draw a triangle, and it can be any size, and it's a right angle triangle. It's got to be a right angle triangle. It can be any size of triangle here. But if it's a right angle triangle, and I know that one of these angles here is 42 degrees, now that becomes my reference angle. That's the one that's important. So now in terms of my relative labeling, this is the opposite side. Down here, this is the adjacent side because it's the side that I'm using to make that angle. And then over here, this is the hypotenuse. Now, the sine ratio is the ratio of the opposite side to the hypotenuse. So if I take the length of the opposite side and divide it by the length of the hypotenuse, that's what I'm going to get here. Now, on my calculator, this is really easy to do. If I give you the angle, it's quite straightforward. Now, most of our calculators are going to be very similar. Okay, I'm going to enter sine, and then I'm just going to enter the angle. Sorry, I just inhaled some spit there. Yikes. So, sine of 42, press enter, and now I'm getting 0.66913, and so on and so forth. And that's what you're seeing right here. Now, it doesn't matter how big the triangle is. That ratio is always going to be true for a 42-degree angle. Okay? Anytime you take the opposite side and divide it by the hypotenuse, okay, when we're looking at when our reference angle is 42 degrees, that's what you're going to get. And that's what makes trig so useful. The fact that it doesn't matter how big the triangle is. I can use that ratio for any size triangle with that angle in it. So that's one way I can get the ratio. Another way I could get the ratio, okay, is if I give you all three sides. So let's say I've given you a triangle here. It says when you look for a ratio and you're searching for two numbers that correspond to the sides listed in the formula here. Okay, so I'm going to ask you for the tangent of z. So here's z. I'm looking for the ratio that corresponds to that. Now, I have to remember the reference angle has to be hinted at or given to you in some way or another here. So I'm asking you for the tangent of z. And remember that when you write out a trig function, it's always going to be acting on an angle. There's always got to be an angle associated with it. If I just write tan and don't do anything beyond that, I haven't finished the thought. It's like asking somebody, what's the difference between a duck and a what? Okay? If you don't finish that, if you don't put an angle there, you haven't finished that thought. So now tangent of z identifies that we're looking at this angle right here. As soon as I do, that helps me label my sides here. Okay, first of all, this is the hypotenuse. Nothing's going to change that. But this becomes my opposite, and this over here becomes my adjacent. So opposite, other side of the triangle, adjacent is the other side that I'm using to build that angle. And so now the tangent of z, tangent is the opposite over the adjacent here, so it's going to be 40 over 30. And then we can divide both numerator and denominator by 10 and just get 4 over 3. And so there we go. That's the ratio that we're looking for. And I mean, you can go to your calculator as well and divide that out, and this becomes, it's basically approximately 1.3 repeating. So 1.3. That's the ratio that goes. And in any triangle, that like if you were to expand this out and like double every side here, triple every side, make it bigger, or make it even smaller, if this is the angle that I'm interested in, that ratio will always be true. Okay? Now, another way I can do this. In triangle ABC, if the sine of A is 3 over 5. Okay. So in this case here, I'm giving you a ratio. It helps to draw the triangle out. Now, you notice here that we're not typically going to find the sine or cosine or tangent of an angle when it's the 90 degree here. We're almost always, and I say almost always because later on it is possible to talk about the trig of the 90 degree here. but we're not there yet. So for right now, that when I talk about the sine of A, remember A is the angle that's of importance here. I'm just going to put A here. And then let's make this C and we'll make this B. Okay? So sine of A is, and I got to think about that, sine is opposite over hypotenuse. So here's my A. This is what's important. So where's my opposite side? Well, that's this one right here. This is the opposite. So this must be where my 3 goes. The hypotenuse is opposite the 90 degrees. So this is where my 5 goes. So I've taken the ratio that they gave me and split it up, opposite and hypotenuse, put it there and there. Now I want the tangent of B. Well, tangent of B, as soon as I switch to this angle being important, now all of a sudden B is the reference angle. So when I started the question, angle A was important. That's how I got my 3 and my 5. Now I'm switching my attention. My attention now goes to angle B, so B becomes the reference angle. So this side over here becomes the opposite. There's nothing there. I'm going to have to figure that out. And then the 3 becomes my adjacent. So I know the adjacent in tangent goes in the denominator, so 3 is going to go down here. Question is, well, what goes up here? What is opposite B? I can use the Pythagorean theorem to figure that out. And remember, I'm going to call this my little b, okay, because it's opposite angle B here. So little a squared plus little b squared is going to equal c squared. So 3 squared plus b squared is going to equal 5 squared. What is that? That's 9 plus b squared is equal to 25. Now, I haven't done much of anything there. I've just squared those numbers. Now I'm going to bring the 9 over. So b squared is going to equal, well, I'm going to subtract 9 from both sides. So it'll be 25 minus 9. So b squared will equal 16. And then I'll take the square root, and the square root of 16 is going to be 4. Okay, so now I know that this side opposite down here is 4. Now I know that the tangent of angle B must be, 4 over 3. Okay, now the last thing we want to do with this particular lesson here is we want to use trigonometry to find an angle that's missing. Okay, and remember there's 2 other things that we're going to do with this, but for right now we want to focus on the ratio and the angle here. And so there are 2 methods that we use to find the measurement of a missing angle. So first of all, if you're given a ratio in the form of a fraction or the decimal, then it's actually very straightforward to find the angle. Okay, we're going to use our calculator here. Now, when you take a look at the calculator, and most calculators are going to be the same. I'm going to make sure this is right up here. Most calculators are going to be really the same here. So this button right here is my sine button. What it does is it takes an angle that I know and gives me what the ratio of the sides should be, the opposite and the hypotenuse. But if I use second sine, it opens up this function up here. And so you'll see the sine to the -1 here. That's the inverse sine function. And what it does is it actually takes that ratio of opposite and hypotenuse and gives me the angle. So if I'm looking for the angle, I actually want to use the trig functions that are up here. The trig functions down here are what I use if you know the angle. If you've actually got a numeric value for the angle, then I'm going to use these guys here to find out the missing, either the missing ratio or the missing side. Okay, and we'll see how that works in the next lesson here. So to start off with, okay, we just introduced this idea of tan inverse, cosine inverse, sine inverse. Okay, and so what we do here, if we wanted to figure out what the angle A was, so let's say I've got this triangle right here, okay, and I've discovered here's my angle A, and I saw that my opposite side was 10 units long, my hypotenuse was 13, so then the sine of A, the ratio that goes along with A, opposite and hypotenuse, is going to be this here. If I want to go backwards and get angle A, what we do is we use the inverse sine on that ratio. Okay, and so what this looks like on my calculator is I would press, I'll walk you right through it here, second sine What that does is that opens up this particular function right here. And inside the parentheses, I'm going to put 10 divided by, 10 divided by 13. And so the calculator is going to assume that I've correctly entered in the opposite divided by the hypotenuse. And when I press enter, it gives me what the corresponding angle is. And normally we're going to round the angle to the nearest degree. So we would say that this is basically 50 degrees. Okay? And there you go. Now, I tried to kind of make these two approaches here overlap. But another thing that might happen here, I might give you a triangle in the question that has 2 out of the 3 angle measurements. So one of the things that we can do here, this is a little bit different. What I did up here is going to be more closely related to what's coming down here a little bit. But another way you can get the angle, and this is much easier here, is just to remember that the angles in a triangle add up to 180 degrees. Okay? And that's one of those things where you'll learn it early on, but after you do a little bit of trigonometry, it's so easy to forget that little rule because you start to look for like more complicated tools, things that use sine, cos, and tan. But I don't really need that. If I wanted to find angle B here, all I got to remember is that these 3 angles here should add up to 180 degrees. So if I want to figure out what angle B is, maybe I'll write it over here first. I'll take 180 degrees. I'll subtract the 90 from it that I've got right there. Then I'll subtract the 36 degrees from it. And what I'm left with is the angle that I'm looking for. So 180 minus 90 minus 36. Okay, well, it turns out that that angle that I'm looking for is 54 degrees. Or, what could be given to me? Well, I could give you a triangle, and I can give you the 2 sides and only the 90 degree. Okay, so you'll just have that 90 degree and then two angles. Then the 2 sides there. So, what I would need to do is I would need to figure out which angle is the reference angle. In other words, what angle is it that I'm actually asking for? Because that will tell me, because if I've got the sides there, it'll tell me whether those sides are opposite, adjacent, or the hypotenuse. I'll be able to figure that out fairly easily here, okay? So then I label those sides here, and then I choose the ratio based on what I've got. Now what that means is I need to know SOHCAHTOA. I need to know that it's sine that puts the opposite and hypotenuse together, that it's cosine that puts the adjacent and the hypotenuse together, and tangent puts the adjacent and the opposite together. If I don't know this, then I won't be able to continue on with a problem like this because I don't know what tool I'm supposed to use. You need to commit that to memory. Now, usually we provide those ratios. The hope is long enough that eventually you won't even need to refer to like a formula sheet. You'll know what those are without having to use that as a kind of a tool to help you with it. And that'll just speed you up through it. The quicker you have those memorized, the faster you can move through this. So then to find the angle, we simply use the second function on your calculator, the inverse function, just like we did a couple seconds ago here. So as an example, let's find angle A. So I've got 2 sides here and the 90 degree. It's asking me for angle A. So the first thing I want to do here is I'm going to identify that this is my reference angle. So that's the angle that's important. That allows me to label this side way over here. This is the opposite. And this side right here, the other side that I'm given, is the adjacent. I know this isn't the hypotenuse because the hypotenuse is always on the opposite side to the 90 degree. So I am given the opposite and the adjacent. So now I got to think. In my SOHCAHTOA, which trig ratio puts together opposite and adjacent? Now remember, these come in groups of 3. Okay, and there it is. Opposite and adjacent, that's tangent. So I can write that the tangent of A, don't know what A is. Remember, that's what I'm looking for. But the tangent of A is going to be the opposite side, 4.3, divided by the adjacent side, 8. Okay, well, I don't know the angle. So the angle is what I'm interested in. Tangent won't give me the angle. Now, I know that it's a tangent ratio that relates the angle to those sides, but tangent's not what I want. If I'm looking for the angle, I want the inverse tangent of 4.3 over 8. So now I go to my calculator. Oops. Make sure that we can see it. So second tangent, 4.3 divided by 8. I'm going to close the brackets there, and when I press enter, I'm getting, to the nearest degree, 28 degrees. And there we go. That's how you use trigonometry to find a missing angle. And remember, my choice of tangent here was simply responding to the sides that we were given and the angle that I'm asking for. Okay? That's how that works. So hopefully that helps make sense of that.